The population of Cache Valley is projected to double between 2020 and 2060. This will pose many unique problems for the valley, not the least of which is providing water for this drastically larger population. With this in mind, the Cache Water District is looking at many alternatives for places to store water, so that when they arise, these needs can be met. The Water District asked White Pine Engineering to evaluate one of these locations, which is the mouth of Temple Fork in Logan Canyon. The Water District was particularly interested in this site as a potential location for a smaller dam, holding around 10,000 acre-feet of water. Who is White Pine Engineering? We are a team of 6 engineering students: Taylor Kessler, Kendall Majan, Riley Manwaring, Adam Pack, John Sumption, and Logan Thackeray. Additionally, White Pine Engineering has received assistance from Drs. Bethany Nelson and Lauren Anderson and Mr. Nathan Doggs from the Cache Water District, as well as a myriad of other USU faculty.
Nate Doggs provided a few key issues to consider at the outset of the project. One was the need to consider the Bonneville cutthroat trout, which the U.S. Forest Service considers a sensitive species. Temple Fork and Spawn Creek, one of its tributaries, are primary breeding grounds for Bonneville cutthroat trout. Another consideration is the known karst formations in the Temple Fork area, which would cause unknown issues with the storage potential of a reservoir there. We explored several options to determine what would best meet the needs of Cache Valley's population while considering the important wildlife and logistical issues. 2 locations were considered as potential dam sites, and the potential storage of a dam at each site was determined using available GIS data and software. Site B keeps Spawn Creek clear of any inundation, but would be unable to store the desired 10,000 acre-feet. Site A is downstream of Spawn Creek, but a dam there would create a reservoir capable of storing 10,000 acre-feet. We chose Site A as the preferred dam site. Next, we chose what the dam would be made of. Our 2 primary choices were earth or roller compacted concrete, also known as RCC. We chose to design an RCC dam due to a lower predicted cost and increased resistance to erosion when compared to an earth dam. We then proceeded to the design phase.
The first step in the design process was research. We conducted a significant amount of research for this project, including looking at similar dams, reading design manuals and available dam studies, and meeting with professors and professionals from both the civil engineering field and the natural resources field. We looked at the hydraulic, geotechnical, hydrologic, and structural aspects of the project. The hydrologic data was used as a starting point for the design. Precipitation, evapotranspiration, groundwater, and runoff data were all acquired through publicly available sources. We used various software provided by the university in making the calculations. For the final design, we decided on an RCC dam constructed at Site A. The height of the dam is 230 feet and features a stepped spillway for optimal energy dissipation. Due to the narrow width of the dam, the fish ladder will be placed on the canyon wall and will allow the Bonneville cutthroat access between the Logan River and Spawn Creek. The outlet works will be composed of 3 6-foot diameter pipes and will have the ability to drain the reservoir from capacity in about 6 days. For more information, come to Senior Design Night to witness the best dam presentation you'll ever see.